Okay, so in our thermodynamics unit, what we mostly did was calculate how much energy we needed to heat or cool something down, depending on the material and depending on how much we wanted to heat something or how much we wanted to cool something. So we calculated the amount of the energy change in doing such things. Um, so something as simple as like boiling a pot of water, we want to calculate how much energy we need to raise the temperature of the water, uh, given how much water we actually have and how high we want to raise the temperature. For doing things like that, for calculating the energy change in a temperature change, we use Q. This formula Q is energy. Q equals mc delta T. Okay, so m is the mass of the substance that we're trying to heat. This matters because, oh well, I'll talk about that in a little bit. C is the specific heat, and this number is a constant. It's going to be different for each substance, but for that substance, it will always be the same. It will just be a number. And what the specific heat basically tells you is how much uh, energy you need to raise 1 gram of that substance by 1 degree C. Or if you want to look at it another way, it's a number that tells you how easy it is or how hard it is to heat that substance. And delta T, sorry, delta T is change in temperature. So T is temperature. The little triangle delta stands for change. So this is the change in temperature that is actually happening. So let's do an example problem. Here's one from the study guide, the thermodynamics unit, number 1. Let's do number 1 from the study guide. How much energy is required to raise the temperature of 200 grams of water from 25 degrees C to 50 degrees C? And the specific heat is 4.184 joules per gram C. That's for water. Okay, so let's do it. Q is the energy we want to find out. mc delta T. What's our m? What's the mass of our substance? In this case, it's 200 grams. The specific heat, C, it's usually given to you. For water, it's 4.184 joules per grams degree C. What that means is it takes 4.184 joules to raise every gram of water by 1 degree C. Pretty high specific heat. And delta T, our last variable, what is the temperature change? Well, we take a look right here. We want to change it from 25 degrees C to 50 degrees C. So that's a change of positive 25 degrees C. Okay, so you just punch this into the calculator, and let me pull mine up here. 200 grams times 4.184 joules per gram C. 184, sorry, it's taking so long. And it's raised by 25 degrees C, so multiply that by 25, and you get 20,920 joules. 20,920 joules. Okay. So that's quite a bit of energy to raise 200 grams of water by 25 degrees Celsius. Requires this much energy. And if you take a look at it, all these variables are just multiplied by each other. So what that kind of tells you is that the more mass you have, or the more of the stuff you have, the more energy it's going to take. And take a look at the delta T, just multiply that also, the change in temperature. The higher you want to raise the temperature, the more energy that's going to take. So something like boiling a pot of water, obviously boiling a small pot of water, a small mass of water, is going to take less energy than boiling a huge pot of water. So it just shows you the relation between the mass and the temperature change. You raise the mass, it's going to require more energy. You want to raise the temperature higher, it's going to require more energy. So that's what the formula means, but in terms of the math itself, I think it's pretty simple. Uh, just look at this here and just note, um, just plug in the numbers. What's your mass? What is the specific heat that's given? And the temperature change that's happening. Okay? So the math is fairly simple, but I also want you to understand what it actually means.